Welcome you all for the section of starters. Okay, today we are going to see about the 2-point, 3-point and 4-point starters. First you have to know what is a starter and why you are in need of the starters. In a DC shunt motor and a DC series motor, you will be having the equation like this: Ia equal to V minus EB divided by RE. V is the supply voltage, EB is the back EMF, and RA is the armature resistance of the shunt motor. At start, when the motor is try to start, the N is equal to, the speed of the motor will be equal to 0. N is nothing but the speed of the motor, which is equal to 0. And the speed of the motor, if the speed of the motor is equal to 0, the back EMF, the generated back EMF will also be equal to 0. Therefore, Ia value, that is armature current, will be equal to V divided by Ra. And we all know that the DC supply, the supply given to the starter, DC supply will be equal to 230 volt, and the Ra value, the armature resistance will be equal to 0.5, and the total current Ra will be Ia equal to 460 amps. Initially, when the motor is try to start, the armature current will be equal to 460 amps. But the rated value of current, if you are going to try to calculate the rated value of current, Ia is equal to power divided by voltage. Assume that you are going to have the power rating as 5 kilowatt, that is 5000 watts, and the voltage is 230 volt. If you are going to divide the 5000 divided by 230, it will be equal to approximately equal to 21 or 22 amps. Approximately equal to 21 or 22 amps. See the value of current, 21 amps and 460 amps. Actually, your motor can able to withstand 21 amps of current. That is the rated value of current. But initially at start, 460 amps is a current is flowing towards the motor, and this current will be around 20 times greater than that of the rated value of current. 460 amps current is 20 times greater than that of the rated current. Okay. If you are going to give that current to the motor, what happens means your motor winding will get damaged. So, you have to reduce the current given to the motor. For that reason, you are in need to have the starters. See, starter is nothing but it is having a starting resistance. You are going to include the value of resistance to the motor. That is, the current has to be flown towards this resistance and it has to reach the armature of the motor. So, the starting resistance represents the starter. Based on the type of connections, you will be having different types of starters. You will be having 3-point starter, 4-point starter and 2-point starter. If you are going to have a 3-point starter, you will be having line, field and armature. If you are going to have a 4-point starter, it will be having line, field, armature and then the neutral point. In a 2-point starter, you will be having line and armature. In the 2-point starter will be used for a DC series motor. In a DC series motor, field and armature will be in series. In a DC shunt motor, field and armature will be connected in parallel. Okay. Therefore, for a 3-point starter can be used only for a DC shunt motor. Okay. In a DC shunt motor, the field winding and the armature winding will be connected in parallel with each other. And moving on to the 3-point starter, what are the equipment present in the 3-point starter means? First is a handle. This is a handle which is present in a 3-point starter, and above the handle you will be having the soft iron piece, and you will be having NVC, that is no volt coil, and overload release coil. This overload release coil and no volt coil is nothing but it is an electromagnet. Electromagnet is nothing but whenever you are going to give a supply to that iron piece or rod, what happens? It will get magnetized. If the supply is removed, then it will demagnetize. Okay. Now see here, this spring, what is the purpose of this spring here means? The handle will be moved against the action of spring. That is, you are going to move the handle from off condition till the run condition, and during the running condition, what happens means this soft iron piece will be holded by this no volt coil. When the supply is switched off, then this NVC will be demagnetized and it will move and it will release the soft iron piece. Because of the action of the spring, the handle will move to the off condition. Okay. Now see the working of the starter. In the starter, you will be having a DC supply which is given to the motor, how the current supply is given to the motor. See, first you have to see about the current supply given to the motor. The current will be flown from positive to the line, and then it will move towards the overload release coil, and then this is connected with the spring and the handle, and from this handle, this point will be connecting the first point, that is stud 1, stud 2, stud 3, stud 4 and the run stud. This off condition, when it touches the stud 1, then it will give the supply to the motor. Okay. The current will be flowing from positive to L, and then to the overload release coil, and then handle, from the handle stud 1, and we are going to move the handle from stud 1 to the run condition. Therefore, if you are going to move the handle from the run off condition to the run condition, you will be moving the handle like this, where it will touch the first point, and then second, where when it touches the first point, you are going to include all the value of resistance to the armature, and when it moves to the stud 2, then R1 is neglected, R2, R3, R4 and RY is included, and when it reaches the stud 3, R3, R4 and R5 resistance is included. You are neglecting the R1 and R2 resistance. Like this, you will be moving the handle from off condition to the run conditions. Now we have moved the handle to the run condition. During the run condition, what happens means this soft iron piece will be held by this NVC, no volt coil, and the supply will be given to the motor, armature as well as to the field. In a 3-point starter, NVC and the field will be connected in series, and whenever there is any problem with the field, it will affect the NVC. Okay. Now, overload release coil. The overload release coil is nothing but when the load is increased, this overload release coil will be activated. Okay. Now you all know about the overall working performance of the 3-point starter. Now see, there is 2 abnormalities present in a system, where whenever there is a field breakout and whenever there is a overload in a system. Whenever there is a field breakout, what happens means, whenever there is a field breakout, what happens means, the current will not be given to the field. There is an open circuit occurs in the field circuit. When the open circuit occurs in the field circuit, what happens? This NVC and the field are connected in series. Whenever the field breakout occurs, what happens means, this NVC will be demagnetized and it will leave the soft iron piece, and the iron handle will move to the off conditions. Okay. This is one abnormality. Why I am telling that it is an abnormality means, see here you all know the formula, N is inversely proportional to the value of flux. That is, the speed is inversely proportional to the value of flux. That is the main flux. Main flux is the flux produced in the field winding. When the current flown towards the field is 0, current and flux is directly proportional. When the current is 0, what happens? Flux produced by the field will also be equal to 0. Whenever you are going to divide 1 divided by 0, then the speed will be infinite. So you should not have the motor, you should not allow the motor to run at very high speed. You have to have the rated speed of the motor. So whenever there is a field breakout, it represents the abnormality of the condition, and you have to switch off the motor, or you have to cut the supply given to the motor. This is what happened for this condition, that when there is a field breakout, it represents an open circuit of the system, and this NVC and the field are connected in series. In an open circuit, current will not flow, and this makes your NVC to get demagnetized, and it will leave the soft iron piece, handle will move to the off condition. It is one abnormality of the system. And the second one is overload. See here, whenever the load increases, that is, you will be giving the motor to a particular rated load, and the load is increased more than the rated value or full load. What happens means, the magnetizing property of your overload release coil will be increased. How it increase means, when the load increases, what happens? The current drawn by the armature will also be increased. When the current drawn by the armature is increased till the rated value of current, this overload release coil will not pull this lever upward. But when it reaches more than the rated value of load, or when it reaches more than the rated value of the full load, what happens means, the current drawn by the armature will be very high, and since the current drawn by the armature is very high, what happens means, this will make your overload release coil to get magnetized in a higher fashion, which makes your lever to pull upward, where one end is connected to the full clamp, which is a fixed end, and another one of the lever end is a floating end, where you will be having this NVC. where you will be having this triangular iron piece. Okay, see here, initially during the normal running condition, this 2 points will be not connected with the triangular iron piece. But when the situation happens that when the load is increased more than the full load, what happens means this overload release coil will attract this lever, and this movable end will move upward, which touches these 2 points. Okay, this triangular iron piece is nothing but it is having the very minimal value of resistance. See here, when the triangular iron piece touches this 2 point, then here you will be having a short circuit. Here you will be having the short circuit with the triangular iron piece. This makes your supply to move towards the triangular iron piece, and it will not allow the current to flow towards the NVC. When it is not allowing the current towards, which is not flowing towards the NVC, means this NVC will be demagnetized and it will release the soft iron piece, and the handle will move towards the off condition. These are the two abnormalities. During these abnormalities, you can able to protect our 3-point starter. Okay, and what is the disadvantage? What is the disadvantage of this 3-point starter means? If you require your motor to run more than the rated speed, that is more than the above the rated value, if you require to make your motor to run above the rated speed, you are in need to reduce the field current. That is, you will be adding the resistance here, and you will be reducing the field current in such a way that the resistance will be included in a higher fashion. Suppose if you are going to do like this, what happens means, then the resistance increases, field current will be reduced. If the field current is reduced, the field and the NVC will be connected in series. When the current flown towards the field is very low, this may make your no volt coil to get demagnetized, and it can able to release the soft iron piece, and the handle will be moved to the off condition. So you can't able to have this kind of starter. This is the 3-point starter for the system which is going to have above rated speed value. Okay, for this disadvantage, you will be going on to the 4-point starter. In a 4-point starter, you will be having the field and the NVC. You will be having the field and the NVC, both are connected in sorry both are connected in parallel with each other. NVC and the field will be connected in parallel with each other, so that whenever you are going to increase the field resistance, what happens means, this increase in field resistance will make your current to get down in the field coil. If the current flown in a field coil is reduced, what happens? We will be having the formula like this: N is inversely proportional to the value of flux. That is, when the field current is reduced, flux will also be reduced. When the flux is reduced, the speed increases. Okay, so we can able to operate the motor above the rated value by using the 4-point starter. The same diagram, but you are going to have a difference in the connection of NVC and the field coil. Here the NVC is connected in parallel with the field. NVC is connected in parallel with the field here. Okay, and what is the disadvantage here means? See here, if there is a field breakout, here the system will operate by itself. But here, when there is a field breakout, since the NVC and the field coil are connected in parallel, with the zero value of field current, this NVC will be taking the current and it will be running the motor. So during the field breakout, this 4-point starter will not work. That is a disadvantage of the 4-point starter. And one more thing, that is, here you will be having the brass arc, here you are not having the brass arc. Okay, in both the things you can able to have the brass arc. What is the purpose of using that brass arc means? See here, whenever you are going to move the handle from first stud to the run stud, the connection towards the coil of field will be flown from R5, R4, R3, R2, R1, and then the current will be flown towards the NVC here. Because of this, what happens means, whenever you are going to have a reduced value of voltage, the current drawn by this NVC will be very low, which makes your soft iron piece to move towards the off condition. Okay, that is why you are going to have the brass arc here, where you can able to avoid the resistance which is flowing towards the NVC. When the current flows towards the NVC. See here, whenever you are going to move the handle from off condition to 1, 2, 3, 4 and the run condition, you can able to have the NVC supply from here itself. You are not in need to have the current which has to be flown from R5, R4, R3, R2, R1 and then to the NVC like this. See here you will be having the run condition and the handle will takes a value of current and it moves from R5, R4, R3, R2, R1 and then it is moving towards the NVC. This can be avoided by using the brass arc. Okay. Thank you.